Hello and welcome to Thinking with Objects, lecture number 1, Introduction in Classes. So welcome to this course. This course is going to go through object-oriented programming in Java. And to take it, you're supposed to, or well, you are assumed to know how to code basic Java. But if you took the last course, Coding in a Cup of Java, you should know enough. So that's fine. But if you didn't take that course, it's still fine if you know the basics of Java. So that's the knowledge you are assumed to know. In the end of each lecture, I have a questions and exercises document, which includes questions and exercises, obviously. So the questions are to see if you have learned everything from the lecture, while the exercises are there for you to practice what you've learned, write some program. And then there's something else called further explorations, where you can take it to the next level if you want to, some more advanced, maybe something that hasn't been covered in the lecture itself. And then in the end of the course there will be an examination with an assignment. So basically you write the assignment, that program, you send it in to me, I mark it if everything is alright, and you pass the course. Otherwise you will have to fix the things that went alright and send it back, and I mark it again. And so that's that. And finally, the software I'm going to use is the same as the last course. So if you took that course, you know that I'm going to use Dr. Java. Otherwise you can get Dr. Java from drjava.org, but and then you have to install it. But since you're assumed to know Java, the basic of Java, you're assumed to be able to get that going as well if you want to use it. Alright, so that was some practical information, some boring stuff, you know. And before I get started, I just want to have a short introduction. What is object-oriented programming? Obviously that's what we're going to talk about throughout this course, throughout this lecture as well. But I want to give you a short introduction. And when it comes to coding, there are a few different paradigms, and these are basically the approach you take to code, to write programs. And one of them are called object-oriented programming, because it's oriented about objects. So you create a bunch of objects and then you use those. And that's exactly what we're going to talk about, what that is. And it's quite handy in bigger projects to have, rather than what we've done before. It's fine what we've done before, but when things get big, it might be a bit tricky to handle. And also, if you take this this course to be able to make Minecraft mods in the future, then it's necessary for another reason as well. Well, Minecraft is written using object-oriented coding. So yeah, that's about it. Let's get started, shall we? So classes is what we're going to use. So a class is sort of a blueprint. So as you can see here on the screen, I have two blueprints. I have one blueprint of a chair and one blueprint of a die. And if I have a blueprint, I can sort of create an object from it, and that's exactly what object-oriented programming is. You create a blueprint. You have to create it yourself. You type code to create it, and then when you have that, you can create objects from it. That creating objects from the blueprint part we've actually seen before, but more to that later. So if we take a closer look on the left blueprint, the one with the chair, it's specifying a few different things, like how big the chair should be and things like that. That could be useful if you build a specific chair. But well, if we have that blueprint, then we can create the actual object. If we have just the blueprint of the chair, that doesn't mean that we have something to sit on, right? So if we create a chair from it, you can use the blueprint and get the chair, and that's all fine. So let's see what we can do with that if we go to coding instead. So let's pop into Dr. Java here, and I'm going to write a simple share example here. And as you might have noticed, I don't know if you have, here on the side I have another file open, and that's a class that I've already prepared. I already prepared the blueprint, so we will only take a look on how to use that blueprint, and later on we will create our own. So that's a class that we're going to use. Okay. So the same thing here, public void, that we've done in the previous course. And then what we can do now is, since I have created this class called share, I can use share as a type, because I've created that type. observe that you can't use it as a type just because you want to. You can use it because, well, I've created a class called share, and I can do my share. That's just the variable's name, and then we can do well, we can create the actual object. So now we have a blueprint called share. I created that one, and to create a new object from it, we just do it like this. So we do a new, and then we do share, and then we do an empty pair of parentheses there. Okay, so we can't really do much. Now we have created the share, but what is there about the share that we can use? What's up with the share? And let's go back and see if we can get something going there. So we have the object here. So we create that object. If we go further, we can see, what if we tell the blueprint that you should have is occupied? That's the method that we want you to have. We want you to have get occupied by, so we get the person that is occupying this share. We might want to get who's occupying it. We might want to set that, and we might want to like empty the share, like nobody's sitting here, set unoccupied. So if we define that in the blueprint, in the class itself, then we can use those when we create a new object of our share. So let's go back and see how that's going to work, like this here. So now I have a share there. So what do I want to do with it? Well, I would like to print some information about it. So let's write a method here called print share information, and that takes one share. So as you can see, I can just use share here as any other type, because, well, basically what I've done is create my own type. So the parameter is type here is share, and therefore I need to, when I call that method, I need to give it a share. But my share is not called that; it's called my share. There you go. So now I can print some information about it, and like we saw in the slide there, I can check if it's occupied. Not just because I want to check that, but because that has been implemented in the blueprint, in the class itself. So now I can check, is this share occupied? Well, if so, I might want to do something. Otherwise, if it's not occupied, I want to print out system.out.println this share is empty. Okay, like so. And if it's actually occupied, then we might want to print out who's occupying the share, right? This share is occupied by, and then we do share, so get occupied by. Okay, so as you can see now, when we want to refer to not by like that, when we want to refer to a method of a specific object of this specific share, we just use its name and then use a dot, and then we use the method. So we have share.isOccupied, we also have share.getOccupiedBy, and then we can just use those like so. So if I compile now, like that, and run it, then I'm going to print out the share. This share is empty, right? However, if I do my share.set occupied by, and then like this, for instance, and then print out the information again, so print share information, like that. If I can spell, that is. So remember, there was something called set occupied by as well, because that was defined. And now it's going to say this share is empty, and then it's going to say this share is occupied by VSWE, because, well, it was just occupied like that. If we wanted to, we could do like my share.set unoccupied, and then print out the information once again. Like that. So now it's going to say that it's not occupied anymore. So yeah, like that. So as you can see here, we're using this share here. We don't really know exactly what's in it. We don't know exactly what the share type exists of. From the slide, it told us that we could use set unoccupied, set occupied by, is occupied, and get occupied by, and it's pretty straightforward what they do from their names, but we don't know exactly what's going on behind the scenes. So that's that. So let's see if we can do this more advanced, because now it doesn't really make too much sense to use this. So let's go back to the slides, and I don't know why they reset. I'm sorry about that. So here we go. Instead of just creating one, when we have a blueprint, you can create multiple ones. So if we have a blueprint of how to make a share, it wouldn't make sense to just make one. If you have some friends that need shares as well, then obviously you make more than one, and you can use the same blueprint for them all. So what I'm going to use now, if we go back to .java again, I'm going to create an array of shares that we're going to use for a more advanced example here. So to do so, how do you make an array? Well, you type the type, and then you do a bracket there, office shares equals new share. Okay, like that. So observe now that I'm not creating any shares at all. I'm creating the array to store them. So remember, when we had an integer array, I had int bracket my integer array equals new int, and then brackets and maybe 10 or something like that. So at the moment we're not creating the shares themselves, we just create the array to store them in. So we have to make some code to actually do that, and a very simple way would be to just loop through the array and just add shares as the elements. And as you might realize, we just do new share like that. So don't mix up when we create a new array and when we create a new object. So they look a bit the same because we create a new of something, but in this case here we have square brackets to tell it that's an array, and then we create the actual array. We don't actually put anything as the elements. So therefore we have to do it like this as well. Okay, so that was that part, and now I want to have a way to print out information about all of these, because, well, I can just print out about a single one, but I want to print out the full information, so it loops through them all, for instance. Then we can do static void print share information. Okay, so I call it the same. It doesn't really matter. It's method overloading anyways. So like we discussed earlier, well, if you took that course, the last course, you can do method overloading like this. We have different parameter lists here, so it's totally fine. Okay, so what I can do now is just loop through them. Length, and then we'll increase that. So we just a normal loop to loop through them all. And what we want to do is, first of all, we might want to print out which number it is. So if you have multiple shares, you might want to have like number 1 is empty, number 3 is occupied, you know. And to do so, the best way would be to just print out a number like that, and then I think like add a dot like that and a space, and then on the next line we can just print out print share information for the specific share that we have. And like any other array, we just refer to it like that. So it's nothing special with this array just because we use our own type. The only thing with it is that, yeah, exactly, we use our own type, but it works exactly the same. So if I compile it now, it's working. And if we want to print out information, I can do print share information like so, and then you just give it our office shares like that. Hit compile, and then it's just a matter of running it all. So now it's going to first print out the other example that we had, and it's going to print out 1, this share is empty, 2, this share is empty, 3, this share is empty, and so on, because all of them are empty. But that's no fun, so let's create a scanner and allow the user to enter some information like this. And then we need to create the actual scanner, and let's do that here when we create the office shares, because we don't need it in the example here. We can actually even remove this example. We don't need that at the moment, like that. Okay, so what do I want? Yeah, I want the scanner. My scanner equals new scanner. Okay, so now when we take a look on the scanner again, you might realize something more. What are we actually doing? Well, we have the scanner type here, we have the variable name here, and we give it the value of, well, we create a new object, we create a new scanner, exactly like when we create a new share here. With one difference, we have something inside the parentheses, the group of parentheses, and we'll see what that is in a few minutes. So we create a scanner like we've always done, and then we might want to use that. So I'm going to do a loop here, so we will do things forever, well, until you want to break out of it, and yeah, system.out. So just to make it a bit better here, so I'm going to print out that this is the actually office shares, and then it's going to print out those shares. And finally, I want to print out the option to exit out of this loop. So then we just do office shares.length plus 1 plus exit. So we tell the user that, well, if you type this number, then well, then we should exit out of the loop. And well, then we just need to ask the user which share to select. So if the user selects a share, we can just refer to that and do things with it. And I want a new line before, so I'm just going to do \n select a share, like that. And then it's nothing more advanced than just my scanner.nextEnd. And as you can see, I'm not actually checking that there is an integer here to read, so the user could crash the program, but examples. So therefore I want to do it like that. But like I showed the last course, it was quite easy to write a method that allowed us to get the next valid integer. Okay, so if the option that the user selected is greater than 1, and that the option is also lesser than or equals to that, which is the amount of shares. So we want to actually pick out a share. Otherwise, if it's equals to office shares dot length plus 1, for instance, that means the user shows the exit, and if so, we want to break out of the loop. And finally, if none of those are correct, then there's no valid option, so now we can just print out invalid option. Okay, so now if we in here, if we have a valid option, then we might want to just grab the share that is associated with it. And there's nothing, like I've said before, there's nothing special using this share type. It just, well, it exists because I've created it before the lecture, and therefore we can just do share selected share, for instance, equals, and then we just refer to the office shares. But since the index of an array starts at 0 and we ask the user to enter 1 or above, we need to do -1, like that. Okay, and then when we've done that, we might want to do something with this share. If it's empty, you might want to sit down. If it's occupied, you might want to ask the person sitting there, "Excuse me, can I sit here for a while?" It would be a bit rude if the other shares were empty, but never mind. It's just a program. The program can be rude. So before we give the user that option, we might just want to print out the information for the specific share, so we know that which share we actually picked. Like that. So print share information. So that's the method we had here. The version that we had with just a share like that instead of the one with the array. And just because we give it one share, it's going to use this automatically. That's method overloading, like we spoke about in the last course. And now we can just ask the object. Well, we can check if the object, so selected share, if it's occupied or not. Okay, so if we do it like that, if it's occupied, then we want to allow the user to well, I'll ask the person that's sitting there to get out of there, but otherwise we might want to sit down. So who should sit here is the question that is presented to the user. And then we can just do selected share.set occupied by, and then do my scanner.next. So since we have something called set occupied here, we can just refer to this selected share and then give it the next name that we enter. And this is totally going to work, even though we have grabbed the selected share out of the array, and then we set something for that share. Just because we pick the value out from the array doesn't mean that we copy it. We just grab the same value. So therefore, when we modify the selected share by doing selected share.set occupied by, for instance, then that's going to affect the share in the array as well, because it's the same. However, if we would do something like equals new share, that wouldn't modify the content of the array. We would basically create a new share and store that in selected share instead. And then if we did something like this, it wouldn't affect the share in the array, because all of a sudden we're using something else. So just a little side note there. We can add a comment here. Allow the user to place a person on the share, or something like that. Or allow the user to allow a person to sit in the share, whatever. But otherwise, we might want to ask the user, do you want to remove the person from this share? You know. Do you want to remove the person from this share? Okay, and then we will just ask the check the scanner. If the user types yes, then we're going to remove it. So it might be a good thing to tell the user, well, yes or no. And then the only thing we can do now, or well, have to do, is my scanner dot next dot to lowercase dot equals yes. And no, I'm not going to allow you to enter last name as well. There's a little problem there if you want to do next line. It's that it's going to find the next line somewhere else, and I'm not going to cover that part right now, and that's why I'm doing it easier with just doing my scanner.next. So it's just like the first name of the person rather than the full name. You can try it out yourself. You get some issues by doing my scanner.next line in this instance, which you can get around, but it requires a bit more advanced code, and therefore I don't thought that it would fit here. So what I'm doing here is, we've seen parts of these before, but we might not have realized what we're doing. And what we're doing here is that we have our scanner called myScanner, and then that's an object. We've created a new scanner up here, new scanner. So that's our object, and we refer to a method, right? We do .next. So we refer to a method, and that's going to return us a value. That's going to return us a string value. A string is not a primitive type. It's an object itself. Well, we have a string class that is built into Java, and then we just create a string object, basically. And when we do dot here, we refer to a method in the string. So we have myScanner.next gives us a string, dot to lowercase gives us another string, and then we check dot equals on that string, which is going to give us a Boolean value, and that one is also using a string parameter. So as you can see here, we're chaining a lot of methods here together without even realizing it. So we do myScanner.next, dot to lowercase, dot equals, and that's going to give us a Boolean value. So if that's the case, that you wanted to say yes, then we want to remove the person from the share. But since we have a method for that, it's pretty straightforward. So then we just do set unoccupied, like that. Hit compile. Oh well, we can add a comment here. Allow the user to remove the person from the share, like that. So we have if it's occupied, then if we want to, we can remove the person. If it's not occupied, we can put the person there. So if I hit compile now and run it all like this, so now we get the office shares. This share is empty, like nothing special. This was what we saw before. But now if I type 3, for instance, then it asks me, well, it tells me that this share is empty. Who should sit here? Okay, Carl can sit there, right? So now we have Carl sitting at office share number 3, and maybe we want to place, I don't know, Bob here. So we have Bob at position 5, and then if we go to share 3 again, it's going to tell us, well, we have a person there. Do you want to remove it? Well, sure, why not? And then we can hit exit there. By using number 6 there. So what we've just done here is we have an array of our own type, a type that I've written, and we can set if a person is occupying that chair. We can check if a person is occupying that chair, and that's pretty much what we're doing. We use set occupied here, set unoccupied, and then when we print it all out, we use is occupied and get occupied by. So it's pretty easy to just set something up like that. Okay, so let's get back to the slides here that always are resetting. Okay, so here we have the blueprint that we created multiple shares with. But let's get going with some more methods here. What if we had something more? Because at the moment we just really what we have is just an array of strings, right? We have just an array of the different names, and if we don't have a name, like we have an empty string or whatnot, a string of length 0 or something like that, then it's just, well, then the share is not occupied. So we could just have a share. We could have a string array called office shares that would do the exact same thing. Of course, we couldn't do like .set unoccupied, .set occupied, but instead we would do like set share occupied and then use the string itself, well, the array, and then just set a string there. It would be a bit more tricky to see what we're doing, but it will still work. It will be a string array. We would store names in there and read the names from there. But what if we want to implement something more, like is broken and repair? Like, I don't even know what they do, but if we wanted to implement those things, it's pretty straightforward. And of course, I've already implemented those in the share class. So for instance, here, so now all of a sudden we have another value. We have the person occupying the share, but we also have if the share is broken or not. You don't want to sit on a broken share, do you? So if it's broken, then I want to print out, well, this share is broken. Well, we can actually even add, please repair it. This share is broken. Please repair it. Like that. So now we have, if it's broken, then we want to well, tell the user that it is. Otherwise, if it's occupied, we tell it who's occupying it. And otherwise, if it's not broken and it's not occupied, then we tell it that the share is empty. And then we might want to do the same thing up here. So you don't want to be able to sit on a share that is broken, because, well, it's totally broken, right? So if selected share.is broken, then we might want to ask the user, well, do you want to repair this share? So let's see. So then do system.out.print print line like so. Do you want to repair this share? And then we give it the same option, yes or no, like that. And well, then we just do the same thing that we did before. We do myScanner, that's our object, .next, that will give us a string, 2 lowercase, that will give us another string, and then finally we do equals, like that. It's the same thing there. And yeah, this is allow the user to repair a broken share. like that. And if it's like that, as you saw in the slide, I prepared something called repair, like so. So first of all, well, I can compile it. First of all, we can use repair and is broken just because we know they are there. From like the documentation, you can see the slide there as a documentation. It told us there's something called is broken and there's something called repair, and we quite easily just implemented that. When we print out the information about the share, then we check if the share is broken. Then print out that it's broken. And if it's broken, we also get the option to, where is it, here, to repair it, because we know there's something called repair. So first of all, from this is, well, we don't know exactly what's going on in the class. Obviously I do, I wrote it, but you don't really know exactly what's going on there, but we can still use it. We know what methods we can use, so that's one good thing. The other good thing is, well, now we have a string value for the person sitting there, but we also have something else, maybe a boolean value if it's broken or not. So we have two values that we need to keep track of, and then we can easily use them by checking if it's broken. We can repair it, we can set who's occupying it. So all of a sudden we're like grouping values together, but also having methods that do nice things, because I can tell you if it's broken or not, it's not a boolean value. So basically each time you sit on a share or stands up from sitting on the share, it's going to decrease the share's durability. So we said Tim can sit there, and then we can tell Tim to stand up. We can tell Tim to sit down. We can tell Tim to stand up, and we can finally tell Tim to sit down once again. But now the share broke. So as you can see now, we have some code in the share class that we can use. We can just refer to it if this share is broken. If this share, if we want to repair this share, then we just do, for instance, that we did up here, selected share.repair. So it's very easy to use, but still there's a lot of things going on there. We have an integer defining its durability, and then when we just do repair, we don't really know exactly what it's set to, because we already prepared that in the share class. So everything gets a bit abstract in a good way, that we don't exactly know what's going on, unless we wrote it ourselves, which is usually the case. But in the outer program, you don't really need to care about that. You just need to care about, well, we want to repair this share, instead of, alright, we have an integer array here with the durabilities, we have a string array with the person sitting there, and then we can check in the integer array, yeah, we changed this durability here, and well, yeah, then, oh right, it's broken now, like checking different arrays. So all of a sudden we have one array with a specific type called share, and then we can ask that to repair itself. So let's see if we can actually repair this. So which share was broken? Number 3, Tim was sitting there too much. So if I do 3, this share is broken, please repair it. Do you want to repair this share? Yes, of course. And all of a sudden it's empty instead, and now Tim can sit there. Like that. So I just improved the program like that with the is broken and repair. And just to make that clear, of course you can't just use repair because you want to, or is broken just because you want to. You have to implement that in the blueprint itself. If it doesn't exist in the blueprint in the class, you can't use it in the object. Right, so let's see what we can do now. If we go back to the ever so resetting slides here, so we have this one, we implemented is broken and repair. But when we create something from a blueprint, everything just looks exactly the same, right? We just get 3, 4, 5, I don't know. In this example, if office shares, we get 5 different shares. They, of course, they can break down individually, and we can place different users on them. We can put different persons on them. But well, when we create them, they are all the same. They are all office shares. Well, they are all the shares. We just do new share and get that share no matter what. What if we could define them to be a bit different? So we have a blueprint. We know how we want them to work, but we might want to change it a bit depending on, well, which type of share we want. For instance, in this example here on the slide, I want a green share when I create it. Then a share is being created, but it's also modified slightly bit. It's green, and then a blue and a red one. So in the blueprint, it's telling me, in the class, it's telling me that, well, this is how you build a share, but when you create it, you can dynamically change it a bit. So if you want a green one, you can do so. Of course, you can't just make it green just because you want to, but you can implement that in the class itself, that we want to allow this specific this dynamic thing. We want to be able to set the color, and that I have implemented that as well in the share class. So what we can do now is, well, to make things easier, I'm going to remove this because we're typing the same thing here all over again. So what I can do instead is just type it out here, so system.print, and since I'm not adding a new line, it's fine. So this share is like that. So now if I run it, it's going to look the same, but we could do something like this, and then we add, so I have a method called getColor as well, that I also prepared. So now we're printing out like this green share is broken, this red share is empty, something like that. And now when we create the share, we might want to actually tell it where's that? Tell it which color it has. So we might want to create a blue share here. So now I'm doing things that we're doing with the scanner. So what this means is that when you create a scanner, you need to send along some extra information. We need to tell it where to look for content, what buffer to check, and we want the standard input to be checked. So that's why when we create a scanner, new scanner, we give it system.in as the first value there. And we do the same thing here. We create a new share, but then we give it blue as a text here for its first color. But we might want to have another color of another share, so instead of looping through the whole thing, let's loop through from the second share and onwards. So now we can do like office shares, and the first one at index 0 equals new share, and we want a pink share, you know? Who doesn't want a pink share? There we go. If I compile it now and run it, here we go. Then I have the first one is this pink share is empty, and then we have this blue share is empty, this blue share is empty, and so on. So what we're doing now is that we create this thing from the blueprint, from the class itself. We're creating this thing, we're creating this share, but we are also allowed to tell it, do you want a green one, a blue one, a pink one, a red one? So we give it some extra information, and that's totally possible. And it's not only like, oh right, we can only give it one value. We can give it multiple values if we want to, but more importantly, we can give it multiple values if we have defined so in the class itself. So we need to tell the class, the blueprint, what we want to give it when we create it. So everything is specified in the class. So object-oriented programming is all about creating classes. You type the code for them, and then when you've done that, you use the object. As you've seen now, we've used the object. We've used the share object that I prepared before. So we haven't actually seen the code for it. But we can do different things, as you saw there. We could create the shares, we can create them in different colors, and things like that. But from this screen here, we have the share object there, the share class there that we used as a blueprint. We defined, what did we define? We defined so we could put a user there, a person. We defined so we could remove the user using set unoccupied. We could get if it was occupied with as occupied. We could also use get occupied by to see who's occupying it, and later on we also used if broken to see if the share was broken, and we also used repair because if the share is broken we might want to repair it. And finally we also added the ability to give it some extra information when we created it. But like I've said, those things are possible. All those things are possible because those are already defined in the blueprint. The share there to the left, and after the break we will take a look on the blueprint on the right, the the class there, the die there. So that one I'm actually going to create with you. So we're going to create a class and then use it. So now we only use the object itself. We have created objects from the blueprint, but then it's going to be about creating the class itself, the blueprint of all the objects, and then use that in an example to randomize some numbers, throwing dice. But like I said, that's after the break, so I'll be back in, well, I've finished a bit earlier now, so in about 20 minutes I'll be back with another 45 minutes when we go through how to create your own class, and then of course how to use that compared to what we actually created. So I'll see you then.